Welcome back, and it's my great pleasure to introduce our next speaker, Professor David Guston, Professor of Political Science and Co-Director of Consortium for Science, Policy, and Outcomes at Arizona State University. He's also Director of the Center for Nanotechnology in Society at ASU. And he's written many books on policies related to science and nanotechnology. So he's also an editor for the journal Science and Public Policy. So he brings with a tremendous background in these policies. So we're going to hear from Professor Guston.
Thank you very much. So in one of the hats that I'm wearing right now is co-director of the Consortium for Science, Policy, and Outcomes. We're in the process of organizing a major conference that is going to take place the 16th to the 19th of May, and I want to say that I understand and appreciate and I'm incredibly thankful for the kind of organization that has gone into this meeting. So thank you very much. It's quite lovely so far and has every promise of being really fascinating as we move on. Here's a quick plan of the talk that I'm going to provide, and in, I guess, the metaphor of the moment, the place where I root myself is probably a bit closer to the legal coast than to the scientific coast in this bridge that we're building. But what I want to describe are the activities of, and particularly the strategic vision of, the Center for Nanotechnology and Society at Arizona State University, which is a bridge-building enterprise in and of itself. And I'll describe to you a number of activities that really go, if you will, from coast to coast across that chasm. And I want to elaborate sort of what some of those things mean for the regulatory process. So, have I got the right? First, I'm going to start with a little anecdote that I'll come back to at the end. And many of you will recognize Louis Pasteur here. Some of you may recognize Bruno Latour. Whoopsie daisy. Some of you may recognize Bruno Latour here, complete with his characteristic ugly ties. And Bruno wrote an absolutely wonderful book called The Pasteurization of France that is incredibly important in my field of the social studies of science. And one of the major themes about it is the successful innovation requires the extension of the laboratory into society. In some aspects, the replication of laboratory conditions themselves into conditions not just in the clinic, but broader into society in order to make things that worked in the laboratory work outside of the laboratory. And Latour tells this wonderful story about how this happens in France for the rabies vaccine. Second part of the beginning of the anecdote is about fear and precaution. And there's a phrase that's been bandied around, and I actually, Alfred probably remembers exactly where and who came up with it. Was it Ari's fear of nanofear? Who knows who actually came up with it? But one of the sort of motivating factors behind a lot of the work that I'm going to be telling you about, in fact, the funding for the work I'm going to be telling you about, is a sort of fear that people who supported nano had of the fear that people who would be receiving nano had of nano. Fear of nanofear. And that's sort of embodied by inchoate references to Michael Crichton's novel, and some discussion that if that had actually ever been made into a movie, the nano enterprise would be doomed, and so on and so forth. And this is tied in many circles and meetings that I had been to in Washington in the early days of my center, 2005, 2006, to issues of the precautionary principle, which in some circles, and I recognize there's no one precautionary principle, and we have to get into all that nuance, but I'll not say crudely speaking, that in some way, shape, manner, or form, ideas about precaution are based in fear rather than in, for example, concrete risk analysis, and that they're also, in some sense, anti-scientific because they cut short the kind of research that might be needed to get to that point of informed scientific bases for risk decisions. And I just found that image when I was searching for that and thought that was really funny. So I'm going to start by giving you these several images and this little story that back in 2006 when I was in Washington, D.C. for the first time as director of the Center for Nanotechnology and Society with my fellow directors of the Nanoscale Science and Engineering Centers, I heard coming from the mouth of the same scientist on the one hand a description of this sort of fear of nanofear and a connection of it to a sort of detrimental or depreciating description of the precautionary principle. Now I'm going to wait till the last part of my talk to give you the second half of the anecdote, but you will hopefully see where I'm going. So I'm going to give you a brief introduction to the center right now, and its background exists in this 21st Century Nanotechnology R&D Act, which was passed in 2003. That's Ray Kurzweil testifying in favor of the act, which incorporated a significant degree, in fact, an unprecedented degree of description of social science and other kind of humanistic and ethical inquiry to go alongside of the nanoscale science and engineering research that the National Nanotechnology Initiative envisioned. And it included the establishment of a research program, the integration of societal concerns, we'll come back to that keyword, integrate, with nano R&D, and it also authorized regular public input into this process. In part based on the authorization in that legislation, the National Science Foundation in 2005 made two large awards at the center level, one to Arizona State, one to my friends at University of California, Santa Barbara, to create centers for nanotechnology and society. And in the 5-year cycle of the NSECs, we were just recently renewed, as well as our colleagues at Santa Barbara. And what we do at the center is, sort of basically the mission that we have is the same kind of research training and education mission that most academic research centers have. And what might be special about it is this sort of partnership, this bridge building, if you will, that we're after with nanoscale science and engineering laboratories to introduce what we call a greater reflexiveness into the R&D process. And that basically means a recognition by the folks who are involved in R&D, broadly construed, that they're actually making decisions that have consequences outside of the laboratory when they're making those decisions inside the laboratory. Okay, so use that as a basic definition of reflexiveness for the moment. The research programs at the center can be divided up into 3 areas, and I just provide the sort of methodological orientation and the thematic focus for you. Briefly, what I really want to concentrate on is this strategic vision here of what we call the center anticipatory governance. And I'll just sort of march through this very quickly and then get to the meanings for the regulatory process. In talking about anticipatory governance, we first want to focus on this concept of anticipation. And you can see from the sort of the etymology given here that anticipation is really about an early capacity building rather than, for example, something that has to do with expectations, predictions, or foresight, although sometimes I will use that term interchangeably. When we talk about anticipation, we talk not about trying to understand what will happen in the future, but talking about a preparation for the multiplicity of things that could happen in the future. Among the things that this concept of anticipation allows us to do is think about engaging with this problem of when do we begin paying attention? And this is an issue that gets bandied about both in the philosophy of science community, in the social studies of science community, and in policy circles all the time. An argument here might be made, and I would in fact try to make it, okay, if science is puzzle solving, and there are good reasons to think that that's not a great metaphor for science, but bear with me for just a second, it is a metaphor that some important philosophers of science have taken to. If science is puzzle solving, when do we begin to pay attention to its societal consequences? Is it when we have the puzzle all completed and we know what it really is? Is it when we have enough of the interlocking pieces put together that we can tell definitively without filling in those last little bits what it really is? And I would argue in this realm of anticipation, and this is where one of the places where I want to lead you to, that maybe it's at a point where as we're turning over the pieces of the puzzle and we begin to see enough white and black and orange and we say, well, is it a pumpkin or is it a tiger? Maybe it's then that we say, oh, if it might be a tiger, then maybe we have to begin to do something about it. A little bit of genealogy of the terminology of anticipatory governance. The concept as a concept goes back a ways. This is Detlev Bronk testifying before the U.S. Congress in support of the National Science Foundation legislation that had been proposed in Science, the Endless Frontier. And he basically gets at the sort of central operational aspect, this bridge building that social scientists may in fact be capable of doing with natural scientists and engineers as their work is proceeding. The terminology itself may in fact be derived from Alvin Toffler's Future Shock. Happy almost 40th anniversary to Future Shock. And there's some details in the literature that I could go into, but the one that I really want to draw out is that there are several familial strands of this, some from public affairs scholars, some from environmental studies scholars, and some from emerging technology scholars. And the difference between what happens in public affairs and what happens in emerging technologies and environmental studies has to do with this disposition of anticipation. It has to do with, on the one hand, early public administration scholars rejecting the concept of anticipatory governance because they reject prediction and see anticipation as similar to it. The great tradition of incrementalism in political science, public affairs, and law sees that prediction is an unfulfillable activity, and so we're going to reject anything that looks like it. On the other hand, emerging technologies and environmental studies scholars embrace it because they conceptualize anticipation as something, in fact, different from prediction, not foretelling the future, but still preparing for it. And this is a slide that actually overlaps significantly with things that you heard from Professor Hall. Okay, that on the governance side now of anticipatory governance, we're talking about a broadly distributed capacity across society that is involved in governance, and we're not simply talking about government regulation. Okay, so this is a space that lies between the sort of ethic of the Chicago World's Fair in 1933, science finds, genius invents, industry applies, man adapts. Okay, there's a very deterministic ethic expressed there, and the kinds of moratoriums proposed by the ETC group and Friends of the Earth and so forth. That oftentimes in emerging technologies like nano, particularly as they start out, you end up with this stark dichotomy between these two options when, in fact, there's this huge array of mechanisms that exists in between those options that exist for a whole set of technologies that we're familiar with. And I want to point out one in particular that I'll be spending some time with, and that's this area of laboratory decisions. And I want you to think about, as we move along a little bit, of the laboratory and not just of the marketplace or the industrial manufacturing facility. I want you to think about the laboratory as a site of governance activities and governing decision-making. Okay, you don't need that slide. It just talks about where I talk about anticipatory governance. Okay, So I want to talk about these various components or subcapacities of anticipatory governance that had been listed on one of the earlier slides. And the first of these is foresight, and I know I told you that foresight or foreseeing is not a synonym for anticipation, but I didn't want to call it anticipation twice. So we call it foresight here because there are an array of methodological techniques that are generally called foresight in the literature that one could bring to bear here. The one that we specifically bring to bear at the Center for Nano and Society involves scenario development, the creation of a variety of futuristic but plausible scenarios for socio-technical development. Okay, and what you see here, for example, is an illustration of a scenario that we developed about a brain-machine interface. And basically what we do is we draw from the technical literature, from the published professional literature, from the fanciful literature, from science fiction, a variety of sort of socio-technical futures. We reduce them to a very concrete description of a technology. We vet them through sort of focus groups with scientists and engineers, and then we develop them into outreach tools, teaching modules, and things of that sort. What we also do is we have scenario development workshops with scientists and engineers about things that they're developing in their laboratories. And in those workshops, we bring together not just the folks who are working in the laboratory, but social science and humanist scholars like ourselves, folks from the user community of the presumed technological development, a variety of experts that exist at that interface. In this case, in addition to the folks in the lab, there were medical doctors, there were nurses, there were health economists, there was someone who was the recipient of an implantable medical device and so forth. And we, at one level, we have some really interesting conversations. In the next slide, I'll give you the punchline of that. And another thing that we do is we engage in what could be called anticipatory product design through a course that we sponsor called Innovation Space, which takes undergraduate engineers, designers, and business students and asks them to come up with a product design prototypes to the extent that they can, and a marketing plan for these activities. And there's a really interesting interaction that happened between that sort of tangible aspect of anticipatory product design and this scenario development activity that we held about a technology known to its developers as Doc in a Box. So this is Stephen Johnston, and he runs a laboratory at ASU's Biodesign Institute. And basically, he's after something called Doc in the Box, where you would, it would be a little tabletop thing where you'd put in a very tiny sample of blood or sputum or something like that, and it would analyze that for up to hundreds, if not thousands, of biomarkers and give you sort of pre-symptomatic disease diagnosis. And what ended up happening when we had that scenario development workshop with Stefan and his group and this social scientists, ethicists, users, doctors, so on, is a couple of things. One, that people in the laboratory, like Stefan and one of his graduate students, began to change their conception of what it was that they were after based on these 2 days of dialogues that we had. And in particular, one student who was working on let's see, is it illustrated here? No. One student who was working on a particular biomarker for a particular disease decided that she was going to change her research. She was going to change the disease for which she was looking for a biomarker, because what she learned about it, the disease that she was working on, didn't sort of have a current treatment, wouldn't have a immediately foreseeable treatment, and based on the values that she had acquired and that she had seen in herself through this process, she decided to change the research that she was working on. Perhaps more interestingly than even that, Stefan, when we went through this process and then through that process of design in that innovation space class that I talked to you about, the putting together of the idea in in a physical place, in this little imaginary box that had until this time, only been imaginary, until this innovation space class got a handle on it and tried, in fact, to design what this interface might look like, conceptually exactly who the output would be connected to, and so on. That really began to transform the thinking of the PI about how this device would work in practice. Okay? So now you're beginning to see the kinds of decisions. What disease do I work on? What are the values that I bring to the choice in disease that I work on? What does the thing that I'm working on, how is it going to be manifest physically in society? How are users going to interface with it? That begin to underlie a number of the kinds of regulatory decisions and complexities that Professor Hall began to explore. Second aspect of anticipatory governance, engagement. Okay, this is putting scientists and engineers and lay citizens together and getting lay citizens involved in a much more concrete way than simply as the recipients of information from scientists and engineers and the rest of us. We have a number of activities in this regard at the Center for Nanotechnology and Society. I won't go through them all in detail, but in the next slide I am going to tell you a bit about our large-scale National Citizens Technology Forum on the topic of nanotechnology and human enhancement, and also something about the Nanoscale Informal Science Education Network, this NISENet here, and the informal science education they do through outreach via public forums at science museums. And what you see here actually was referred to earlier. This is a meeting in Cambridge, Massachusetts, about the question of local regulation of nanotechnology. And what the Boston Museum of Science did was they put together, in concert with the decision makers and the scientists and engineers in the Boston area, a public forum at their museum to discuss in a fairly robust public way the whether or not the question of whether or not Cambridge would sort of replicate the regulations for nanotechnology that had been passed in the city of Berkeley. So, regulatory meaning of engagement. What we did at ASU was we organized a National Citizens Technology Forum. It was located in 6 sites across the country. It took place over a month in the spring of 2008, and it had about 75 participants across these 6 areas in geographically dispersed portions of the country. The first weekend, they spent face-to-face around tables such as these on academic campuses, and they had previously read a 60-page background document that we prepared for them. They took pre-tests. They spent a solid weekend discussing the issues that they had learned about, and then over the course of 3.5 intervening weeks, the 6 sites interacted through an internet program that enabled them to converse with folks at geographically remote sites from them, to query experts in the sciences and in social science and ethics as well. And then in the final weekend of the month-long process, they came back and met face-to-face again in their specific sites and wrote some reports, and then took a post-test. And the process-related findings from the pre-test and the post-test demonstrated that the National Citizens Technology Forum process that we designed had an important and statistically significant impact on the way these folks were thinking about nanotechnology. First, they had statistically significant increase in opinion holding about the relative risks and benefits of nanotechnologies for human enhancement. They demonstrated a statistically significant increase in knowledge. There was congruence between individuals and groups. That means basically, overwhelmingly, the individuals said that their opinions agreed with the group's opinion. There was congruence among the regional groups, although there were some things that you could identify that might be sort of regional specializations, if you will, in the reports. And there was no evidence of what deliberative theorists call polarization cascades, which is basically, again, to avoid saying putting it crudely, but when one loudmouth takes over the discussion and cows everybody into believing that they're right simply by virtue of their intensity of feeling, or that the initial majority merely predicts the end state majority. There was no evidence of either of those activities. And what we found substantively was that the deliberative activity reduces support for specifically enhancement applications based on the kinds of scenarios that we developed that I described to you before that we provided for them. It reduces support for non-therapeutic interventions, but not for therapeutic interventions. And it does not dilute a general optimism about nanotechnology. So what you saw was lay citizens making what looked to be really informed kinds of decisions, making distinctions between different types of applications in different kinds of ways. It also, and this is sort of a nice result for the deliberative theorists, increases feelings of what we called internal efficacy. That is, the citizens' own perception of their ability to handle these complex issues. Unfortunately, it decreased their feelings of external efficacy, which was, now that I can understand this, now that I have a feeling that I can do this, what do I think are my chances of actually being able to influence the world in how this stuff gets done? And so I think the sort of take-home for the meaning for regulation here about public engagement, the 2003 Act authorized it, the methods are ready, and are the agencies ready? Are the regulatory agencies ready to begin trying to understand how public engagement of this sort can feed into the regulatory process? And let me just add that it's not just feeding into the regulatory process as such, but also that if you take a look at what happens in the National Nanotechnology Initiative and the funding of the initiative that happens, of course, relatively independently, but through some coordinated fashion across a large number of federal agencies, that funding is broken down in the budget analysis into a set of program component areas, PCAs. And there's, in the NNI literature, you can see which agencies are supporting research in which of these program component areas. And one of those program component areas, PCA 8, is about education and the societal aspects of nanotechnology. And over 90% of the funding in PCA 8 comes from the National Science Foundation. The greater portion of the rest of it comes from the National Institutes of Health, teeny weeny bit from the Department of Agriculture, teeny weeny bit from the Department of Energy. There is no logged money. Now, these budgets get put together in different ways, and certainly things get missed, and I'm informed by somebody who knows the DoD budget, for example, very well in Nano, that there are DoD activities that are not logged in the official records of PCA 8, but there is no logged R&D spending by FDA, by EPA, for program component area 8. Integration. This is, again, harks back to the term that was used in that 2003 Act, and basically what we mean by it at CNS-ASU is putting social science and humanist research together in close proximity. We use the term embedding with nanoscale science and engineering activity. And a major aspect of this is a separately funded but associated project called the Socio-Technical Integration Research Project, led by Eric Fisher here in the lower left corner. And that's one of the STIR students, Shannon Connolly, who is a political scientist who went into some labs and actually turned into a fairly competent PCR technician. We have a variety of both research and education and training programs, but what's interesting about the STIR project is that unlike other sort of ethnographic entrees into laboratories that social scientists and humanists may do, we're after something that's not just a thick description of what goes on in the laboratory, but we're also not interested in marching into the laboratory and saying, we're the bioethicists or we're the nanoethicists, we're here to tell you what to do. And so Eric developed this sort of really interesting protocol that splits the difference between those two different things, and it's basically a sort of Socratic inquiry in the context of the laboratory about what the folks in the laboratory are doing to get them to a point of understanding. I'm sorry, that's a little fuzzy. Get them to a point of understanding that laboratories are sites of governance as well. And get them to that point of reflection that I described to you earlier, of understanding that they themselves are part of a decision space that exists in the laboratory, that expands out to the university, that sits in a set of streams that authorize, like that 2003 Act, some criteria for responsible innovation that goes down to the layer of, say, the National Nanotechnology Initiative, one of whose 4 strategic areas is responsible innovation, and to imagine how laboratories actually fit into that decision space. And what the STIR students have discovered, what Eric discovered in his first time doing this protocol himself when he was a doctoral student, and I'll relate his story in particular, through his interactions with another student in the laboratory that he was studying. Basically, the student was at a technical dead end, and through this dialogic process with Eric, managed to find a way around the dead end. And oh, by the way, in the process of doing so, ended up making a choice about materials that were being used that, should the experimental system that the student was engaged in be scaled up industrially, would be more environmentally benign than the experimental system that the student had been working with previously. Okay, so here again, laboratories are sites of governance as well. There are decisions that are made in the context of the laboratory, and through this process of collaboration, we can engage and, in fact, begin to tweak the kinds of decisions that get in toward social goals that we might have. Another area where we're working with this is not immediately into the regulatory space yet, but we have a new thematic area that we call urban design materials in the built environment, otherwise known as nano in the city. And you could imagine, for example, things that happen that we've heard about in terms of regulation of nanomaterials in foods and drugs and cosmetics and as pesticides and as chemicals. A lot of what we hear about nanotechnology is about structure and function and strength and active structures and so forth, all sorts of applications for the infrastructure of cities, the way we build, the way we live in the things that we inhabit. So there's a whole regulatory area that we haven't heard of yet about, for example, building codes that might be important to look at. And in fact, we've started down this road with a graduate course, a studio course that we've been teaching now this past year, Sustainable Anticipatory Governance in the Future of Phoenix. And this happened because Carol Johnson here, the manager of the city planning office in Phoenix, heard about this concept of anticipatory governance, came to us, and we, in fact, enlisted ourselves to assist the utterly unfunded planning department to fulfill their legislative mandate of planning for the city of Phoenix every every 10 years. And we basically went through this process of designing scenarios, of involving stakeholders and lay citizens across the city in trying to imagine the variety of plausible futures that the city of Phoenix might have against a sort of technological backdrop. I'll skip over that part if you want to ask me about anticipatory governance as an assessment or evaluation scheme in a Silmar. Please do so. So I'm back to the anecdote now. So recall that I was in Washington, D.C. I was listening to a chemist who was a fellow director of a National Science and Engineering Center talk, and he was saying that the real problem is that people are afraid of nanotechnology, and they went out and read Prey, and they really don't know what nanotechnology is, and there's, and that's why they want to be precautionary about it. I would bet that someplace in that chemist's laboratory, or at least in one of the laboratories in that chemist's center, is this thing, which is a hood under which chemists do their experiments. Now, that hood exists for a whole mess of institutional reasons, and maybe someplace way back in deepest, darkest history, there's an honest-to-goodness risk assessment that went with it. And yes, it's probably the case that academic chemists don't do remarkably well in workplace safety, but if you think about the combination of the safety protocols that exist in the context of the laboratory and put them together with the social aspects that go on in the laboratory about safety and about health and about precaution, it is certainly the case that 100% of academic chemists have health insurance. It is certainly not the case that 100% of people who would be exposed to nanomaterials have health insurance. So when we think about this process of expanding the laboratory to make for a successful innovation, we often think about how to control, in the laboratory experimental sense, the material that goes outside of the laboratory. And I would argue here that what we also need to do is think about, because laboratories are social and precautionary, what if we expanded the social and precautionary elements that go on in the laboratory as a way of thinking about governing emerging technologies like nano? Let citizens have anticipatory, engaged, and integrative experience with emerging technologies and protect them as we do the scientists. And that's a meaning of anticipatory governance for the regulatory environment. And thanks to the organizers, and thank you to NSF. Now that's a nasty one. Just a couple of thoughts that come to mind. First, that certainly connects with what I would call the politics of novelty that we've heard a little bit about before, and then I expect will come up in more discussion. That is, in order to get funding, you need to make certain choices. In order to get out into the world, you may need to make other kinds of choices. But also that conversation happens in a variety of places and a variety of arenas, and so it might happen in it might happen in the mass media. It might happen in the context of a laboratory where doctoral students in the sciences and engineering that we work with talk to us about the relative neglect of the unanticipated or easily anticipated but still downside consequences of the kind of work that they're doing. They can all see, for example, the nasty dual use or terrorist garage do-it-yourself kinds of applications of what they're doing, and yet they have no forum in which to engage in those discussions, even while they think that the net benefits for society are going to be better should this pan out properly, and they still yearn for those kinds of discussions. Yeah, I mean, another aspect of that as well is that when you surveyed, our group surveyed nanoscientists and engineers back in 2007 and asked them about risks and benefits of nano. And for the first time that we could tell for an emerging technology, sort of looking back in GM food, looking back at nuclear, the folks who were sort of most expert in the area perceived greater risks in some areas than the lay citizens did. Okay, so particularly in health and the environment, the nanoscientists and engineers that we surveyed, these were not just any nanoscientists and engineers, they were in fact people that we drew from a specific database created, and we took the most highly cited slice off the top and surveyed them. And they were in fact more concerned about what was going on, and yet that sort of was not part of the discussion back in 2007.
I have a small question. You mentioned at the end that in the lab, you showed the picture of the board saying that we are practice on safety, but in the technical community, we should keep the same thing. But isn't it true for all the product development? When the industry makes a product, they make sure that they follow the safety standard to make those devices, and then they put it in the market. So why this should be something different from that point of view?
I'm not quite sure I'm following. I mean, the point of the hood is that the aspiration for precaution that is often expressed from civil society is not can't be characterized as an unscientific aspiration. And yes, practices will differ, and and compliance is going to differ, but just that it can't be characterized as being unscientific.
You mentioned on your the discussions in the 6 sites with various people and how they responded to nano before and after. And you mentioned this point about their enthusiasm for therapeutic interventions was right up there, but the whole process decreased their enthusiasm for human enhancement.
Yes.
Could you tell us more about that, and especially how they were making the distinction between the two?
The distinctions between the two, excuse me, the distinctions between the two came almost entirely out of a set of 5 or 6 scenarios that we gave them to work with, where there were a couple of therapeutic scenarios and a couple of enhancement scenarios. And so, you can say, and is often argued, analytically, it's very hard to distinguish between therapies and enhancements. And as we heard about the comment from, off-label use, if one imagines, the intervention as a drug, there's very little that one can practically do under sort of current regulatory regime to prevent a therapy from being used for an enhancement purpose. But it was grounded in the particular socio-technical scenarios that we gave them, and the particular point is that beyond there being an attractiveness to the public, to these publics, for an analytical distinction that's very hard to make, that they are in fact able of making relatively fine distinctions among specific technological applications. And I'll point out, actually, there's another public opinion survey that we have that's the focus of Sean Hayes' poster there, where we continue to see how particular segments of the public can make relatively refined distinctions about these therapy and enhancement technologies as well.
Okay, what we'll do is we're going to have a discussion so we can continue these questions and answers during the discussion time. Let's thank all the